Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're starting a new unit, and the topic is functions. So today's lesson is specifically titled Relations and Functions, with functions being the overall idea for this unit. So as we jump in, you have four diagrams here, and they each have an input box and an output box, and they have arrows going from the inputs to the outputs. So what I want you to do is see if you can split these diagrams up into two groups of two, where each group has the same characteristics when it comes to how the arrows are being drawn from the inputs to the outputs. Okay, so don't focus on whether the numbers are negative or positive. Those shouldn't be the characteristics you're looking at. You're specifically looking for how the arrows are being drawn from the input to the outputs box. Okay, take about 60 seconds, come back, and join us for a discussion. Okay, so I am going to put number 1 and number 4 in the same category. And I'm going to put number 2 and number 3 in the same category. So if you had these categories, maybe you thought of the same characteristics that I'm going to put forth. If you didn't think of these categories, maybe pause the video again and see why you think I labeled 1 and 4 within the same category and 2 and 3 within the same category. So if you notice, 1 and 4 both have an input that goes to two different outputs. So if I look up here at number 1, 0, let's do red, 0 goes to both 1 and 2. If I look down at number 4, 2 goes to both A and B. So for 1 and 4, they both have an input that goes to two different outputs. If you look at numbers 2 and 3, that doesn't happen, right? Each input goes to exactly one output, right? There's only one arrow going off of each input value. This is our very first introduction to functions, right? 2 of these represent functions, 2 of these don't represent functions. And again, we don't really know what functions are, but at the very basic level, or we don't know what they are yet, but at the very basic level, this is why 2 and 3 are functions and 1 and 4 would not be functions. It has to do with, do the inputs go to just one output, or do they go to more than one output? So again, number 1 would be not a function, and we'll nail down this vocab in a second. Number 4 would also not be a function. Number 2 is a function, and number 3 is also a function. Let's go to the next page and really try to tie down these vocab words. So we start with a relation, which is a set of inputs and outputs. So all 4 of those examples up above were relations because they had a set of inputs and they had a set of outputs. You can think of the inputs as domain values. These would be our x values. And you can think of the outputs as a range. These would be our y values. So these two words, domain and range, we're going to be using them quite frequently, pretty much not only for the rest of this course, but for the rest of your high school math careers, because functions play a large role in those courses. So domain, that represents the inputs, or we can think of these as our x values. And range represents the outputs. We can think of these as our y values, right? If we have a graph, x values on the horizontal axis, y values on the vertical axis. Okay, moving into functions. Functions are a type of relation in which each input from the domain is assigned exactly one output from the range. So if you think back to up top, right, for the non-functions, there were 2 arrows going from some of the input values. That's not allowed for functions. There can only be exactly 1 arrow going from an input to an output. An input can only have 1 output. That being said, you can have multiple inputs that have the same output, as long as each input has only 1 output. So instead of erasing all this and going back up top, let me just show you what we mean by that. All right, let's say this is our input box. Here's our outputs. We'll have 3 inputs. And again, I could choose whatever numbers I wanted here. So for functions, right, 1 can only go to either 6, 10, or 12. It can't go to more than 1. However, 2 could go to the same output as 1. Right? It's just that 2 could only go to that output and it couldn't go to another one. Right? If 2 went to 12 as well, then all of a sudden this becomes a non-function. Right? So you could have all 3 of your inputs going to the same output value as long as they're only going to 1 output value. You don't have to have all of your outputs used here. If they weren't being used, then we would, this is going a little bit further than we need to right now, but they wouldn't be considered part of the range, right? The other words for inputs and outputs, domain. That was a little poor. Let's try that again. Domain and range. So realistically, if all 3 of our inputs went to 6, we actually just wouldn't include those outputs in there at all because they're not being used. Okay, let's get some practice deciding whether relations are functions. Remember, relations are the big category, right, if we're thinking about our Venn diagram, and functions, so that if the red represents relations, functions are a subset of relations. So all functions are relations, not all relations are functions. And if you have trouble digesting that phrase, pause the video, listen to it again, look at the Venn diagram. Not every relation is a function, but every function is a relation. All right, let's get some practice in. So we have 8 problems here where we have to decide whether these are functions or just relations. And if they're not a function, we've got to state why. So we're not going to do all of these. We are just going to do the odds, so the left-hand side. So we're going to start with 1. My suggestion is that you pause the video, try to figure out whether it's a function or just a relation. And if it's not a function, be sure to state why. Just do number 1, listen to the explanation. If you were correct, then you can feel confident moving on to 3 and the other ones. Okay, so for number 1, we've already gone over an example like this, but 3 is going to both 6 and 7, which means this cannot be a function because the input category, right, that's the domain category. We have an input going to 2 different outputs. So not a function because 3 goes to both 6 and 7. Another way you could also say instead of goes to both, you could say is mapped to both. When we're talking about inputs going to outputs, we can say an input is mapped to a different output. That's another vocab word you may hear thrown around. Mapping just means we're taking an input and mapping takes that input to a specific output. Let's go to number 3. We have these written a little differently here, right? The inputs and the outputs are not in a diagram. They're written as coordinates. We've seen these before, though. We understand what coordinates are, and we should understand that the x values come first, the y values come second. Remember, the inputs, those are our x values. Those are the domain. And the outputs represent the y values. So think about that as you try to determine, are there multiple inputs, is there an input with multiple outputs? And we can see that there are 2 of the same input values here, right? 5 goes to both 2 and 0, or 5 is mapped to both 2 and 0. So if we were thinking about the diagram right here, right, 5 would have 2 arrows. One would be drawn to 2, one would be drawn to 0, which isn't allowed for a function, right? Each input can only go to one output. So we would say not a function, because 5 is mapped, or you could say or goes to both, is mapped to both 2 and 0. So again, this is just another representation of a relation, right? We could represent a relation with the diagrams from up above. We can represent them with ordered pairs like we have here, or we can represent them with graphs like we have for our next 4 examples. Go ahead. I'm not going to give you any hints yet, but think about if you could figure out whether there is an input with multiple outputs here, and maybe think in terms of x and y values. So if we look at this graph right here, and we just plot some points, right? There's an infinite amount of points, so we're not going to plot all of them, but we can plot some. We have this point, -5, 5. We've got a point here, -2, 2. We've got the origin, 0, 0. We've got 3, 3. And remember, we're trying to see, is there an input? Is there an x value that has multiple y values? Well, let's check the x value of -5. Right? If we look at -5, well, there's only one point on the function. When x is equal to -5, it's up there. So -5 doesn't have multiple outputs. It only has one. It only has 5. Same thing with actually all of these other points, right? If we look at -2, -2 only has one output. It's +2. May look like a 1. Let's make sure we know that that's a +2. Right? And as we move along, we can see that there's clearly only one y value for each x value here. So we could say this is a function. Go ahead and try number 7 down below. Okay, so for number 7, I think we can see that the same thing holds, same idea as up above. For each of these x values, like if we just take -4, right, there's only one y value at x equals -4. It's just this point on the function. So -4 is only being mapped to positive 3. And again, that occurs for each of these x values on the line. If we take a look at number 8, there's a difference here, right? And I think we can see it right away. What x value has 2 points above it? Well, if we look at -1, -1 has at least 2 points, right? It actually has more than 2 points because it includes all these points in between as well. But we can just label the 2 that are given. We have -1, 1. We have -1, 4. And we could keep listing a bunch of other points on this line. Right? There's all these other points that we could come up with coordinates for. So in this case, the input -1 is mapped to many different y values. Right? And you only have to show that it's mapped to 2. Right? It doesn't matter whether it's 2, 3, 4, or infinite. As long as it's mapped to more than 1, we can say it's not a function. I guess we should write function over here because we decided it was. But over here, not a function. Because -1 is mapped to 1 and positive 4. And we can also say and many others, right? We don't just want to think it's only those 2, because it includes all the other points on the line connecting those 2 points. Now there's a very easy way to determine whether a graph is just a relation or whether it is actually a function, and it's called the vertical line test. For this test, you want to have a pencil or some type of ruler or something straight that you can move along your paper. I'm going to use this white object here that I can move back and forth. And what you're going to do is you're going to start it next to the graph, and you're just going to move it horizontally from either right to left or left to right. As long as your pencil or ruler never intersects the graph more than once, right? You can see as I'm moving this, it only touches the graph in one point. Let me just put some points here. Right? And you're only talking about one side of your pencil. You're not talking about both sides. So I'm going to need to pull this up again. So as I move this, it only touches one of the points at any given time. Right? So that's why this is a function. It doesn't break the vertical line test. If I go over to number 8, it's okay. It's until we get to -1. But then right there, right, it touches multiple points at the same time, which means this graph breaks the vertical line test, meaning it's not a function. Right? It's okay, even if I keep going over here, it still only touches one point at a single time. But when I get to right here, right, the side of my ruler is touching multiple points at the same time, which makes it not a function. So that's called the vertical line test. It's a very quick visual test to determine whether a graph is a function or not. Let's move on to our last page. Get some more practice in. We're actually not going to go over these on the video, but I'll just explain what's going on here. You get to now create your own relations and functions. This should say functions. So the first set of 2 problems, you're going to draw the 2 charts. Right? We have an input diagram, an output diagram, and you could put numbers or letters in between. You'd have arrows going across. Okay, you then draw another set, and one of these must be a function. The other one must not be a function. It can only be a relation. So 2 things for you to do for number 1. Come up with a function in this form of a diagram and just a regular relation. For the second question, you're doing the same thing. You're going to create a function and then something that is a relation but not a function, but now we're using tables. This would be very similar to coordinates, right? You have your x's and your y values. If you forget, you can go back up or listen to the video again and to figure out whether your x's are your inputs or whether your y's are your inputs or outputs, and then start to create a table, one which is a function, one which is not a function. The third and final problem has you drawing two graphs, one that's a function, one that's not a function. So 6 problems to do in all, because there's 2 parts for each of these. And hopefully this really helps you hone down those key differences between functions and relations that are not functions. Remember that key phrase from before, every function is a relation, but not every relation is a function. A real-world example would be, if you told someone you play soccer. Well, if you play soccer, somebody could also say that you're playing a sport, right? Because soccer falls in the bigger sport category. But if you tell someone you're playing a sport, well, they don't know if you're playing soccer or if you're playing football, if you're playing basketball, etc. So soccer in this case would be like functions, whereas sport would be the bigger relation category. Okay, we are going to stop it here. As always, enjoy the rest of your day, and we'll see you back here next time.